Where am I? There I am. Welcome to week 8 of cis204, Unix Shell Scripting and Utilities. Um, week 8 lecture, like the other lectures, will be broken down into 3 parts. Week 8 is kind of an odd duck week in the sense that I'm going to spend some time as soon as I knock down this cheesy camera talking about the Linux boot, inodes, and useful utilities. Um, I have had a Linux image running on a machine, probably at least one of my machines, since the early 2000s. Again, I've been around Unix for a while, so Unix is not something that um, is frustrating for me, as it may be for some of you. But Linux is a decent operating system, and at one time there weren't a lot of applications available in the Linux environment to make it worth your while to give up either the Mac or the Microsoft environment. In fact, there are tools in the Mac and in the Microsoft environment that would tend to preclude you from wanting to go to Linux if you were a power user of those tools. I know that a lot of graphics design people and photographers use Macs and love Macs. Their ability to run Adobe Photoshop and some other tools are one of the reasons Macs are as highly valued as they are. The downside to the Mac is it's a proprietary operating system in the sense that at its heart, it's part of the Berkeley software distribution. There's Unix underneath it, but at the same time, Apple has a lock on what's and how things will be updated and what tools are available to you. Hardware is a bit pricier than the equivalent in the Microsoft world. Microsoft was strictly concerned with the software and not with the hardware. And because Microsoft grew up providing the OS for the IBM PC. So they did not have the same outlook when they started as Apple did. Apple was a complete provider of both hardware and software. Well, subsequently, yes, there are third-party hardware pieces. In particular, if I remember correctly, things like the Lacey monitors, Lacey hard drives, that type of thing that allow the Apple environment to deal with some of the photographers' pressing needs and graphic designers' needs. And then on the Microsoft side, some of the power tools for business are there that pretty much preclude you. Once you get locked in, they kind of preclude you from looking at anything else. I will say that at some point, the city of Munich, Germany, decided that they did not want to be locked into a Microsoft distribution process. And in particular, they were worried that they weren't getting updates. Now, this was a number of years ago, updates as frequently as they needed them. There were too many holes in the security, that type of thing. And they decided they were going to go with Ubuntu Linux. And they actually made that happen. And that's an interesting story. And if you go out and look for it, it's Limux. Limux is the project that Munich did. So now that I've wasted about 5 minutes, let's talk about Linux boot, inodes, and useful utilities. If you do decide to put a Linux image on your machine, generally what can happen is you've got a disk drive that's divided into separate partitions. One partition will be able to boot Windows, another partition will be able to boot a Linux image. So at some point there has to be a screen that says which one of these do you want to boot, and that's known as a grub screen in the Linux environment. So you see this grub screen and you pick which one of the operating systems you want to load. The operating system that you want to load is pointed to by the BIOS, and then it loads that OS, and the OS loads itself and brings up all these pretty GUI things and that type of stuff. So you could do Windows or Linux. My laptop is a single boot. It boots Linux only. My desk side boots both Linux and Windows 7. And I want to give you the caveat that this stuff works okay in Windows 7. I had problems with Windows 8. I think there are ways around it, but it's a little more difficult to dual boot Windows 8 and Linux because Windows 8 tends to do some nasty things to the grub process. Windows 10, I've not had any experience with Windows 10 and dual booting a machine, Linux image or otherwise. Now, there's another thing that can be done, and that is putting a virtual box in the system. So somewhere around here, I've got something called VirtualBox. And if I bring up VirtualBox, and I'll do that, and I'm spending more time here, but here's my VirtualBox. Oh, look. I've got a Solaris Oracle operating system. Let's do this. Okay. Let's bring it up. So Oracle has a virtual machine manager called VirtualBox. Problems. Alrighty. Failed to open a session for the virtual machine. Let's take a look at the details for grins. Okay, session machine. Yeah, NS error failure. Okay. So I had an issue bringing it up, but let's see here. Let's start the session. Okay. So we'll bring up Solaris here. Comes up in this virtual box. Okay, let's just get rid of that. So, let me do something here. Let's get back to this. The reason I wanted to show you this virtual box is because the fun thing is that you can actually get another environment running inside an existing operating system. So I'm trying to bring up Solaris while I'm actually running Ubuntu in the background. If we go to, let's take a look at this. We go to Oracle VirtualBox. You can see that VirtualBox is available. It's available for Windows, Linux, Mac, and if you bring it up, you can then load in the VirtualBox. You could load a Linux image, a CentOS image, or whatever else you wanted. And as we can see, this is beginning to boot. So we'll just keep that in the background and let it play. Let's go to slide 2, not 12. So what is the boot sequence in a machine? On a PC, the boot sequence is the basic input-output system executes what is known as the master boot record. The master boot record executes the grub, which is the Grand Unified Bootloader, and that starts the kernel off. The kernel in our case will execute the sbin init or the sbin systemd or bin systemd. Init will then control all of the run level programs. For instance, init then controls the screen, basically, the GUI. So that's going on. And there are a series in the Linux environment and the Unix environment, there are a series of programs that occur at every run level. So there's run level O through, I think, 6, if I remember correctly, or maybe O through 5. But there are an etc, rc.d, rc splat, which is the run level name .d, and those programs are run as the machine goes through its run levels. So this is what a BIOS looks like. It's actually a basic input-output system. It's a EEPROM, erasable electronic program read-only memory. And it's read-only, but it's not read-only. It can be written too. Basically, this controls how your machine looks at the hardware. The BIOS is how you get from point A to point B in your system. How do you make the input-output work? It knows about the keyboard, it knows about the output, the terminal, it knows about the disk drives, that type of thing. The master boot record is an area on the disk that size is 512 bytes. There is a code area, and then there is a 64-byte table of primary partitions. So there are 4 16-byte partition structures that are known. Then there are a signature that's sitting at the end of this master boot record, and it's 55HAA. So it's a hex 55 and an AA in hex. Okay. The GPT these days, as we move forward, master boot records are still in use, but they're being slowly replaced by this GPT, the GUID partition table. It's a partitioning scheme that's part of the Unified Extensible Firmware Interface, and it uses a globally unique identifier for qualifying devices. So the next generation of machines and the partitioning scheme for those machines is designed to succeed this master boot record that we have been using and replace it with this new partitioning scheme method. Its necessity evolved to deal with several shortcomings that the MBR scheme method and it offers additional advantages. So there's a wiki link here for that table, or the partition table, the GPT, and you may want to take a look at it if you're so inclined. The GPT, the Globally Unique Identifiers Partition Table, is sitting out there. If I did this and it basically SUD partition -L on dev SDA, it shows me that it's an ATA Hitachi. It's a 500 gigabyte device. It shows me that the logical sector size is 512 bytes and the physical size is 4K. The partition table is GPT on this device. I have a partition 1, which is a boot partition, a partition 2, which is an MSFT data, and partition 3, which is the logical volume manager, which has the rest of the data in it, including, the home and my documents and everything else are sitting in the logical volume manager partition. Grub, which is the Grand Unified Bootloader, is a bootloader. It's the first software program that runs when a computer starts. It's BIOS runs, grabs the grub, master boot record grabs the grub. So it's a bootloader, first software program that runs when a computer starts. It's responsible for loading and transferring control to an operating system kernel software, such as Linux or GNU Mach or Windows. The kernel, in turn, initializes the rest of the operating system. So the kernel is just what it says it is. It's a kernel. It's a small piece of the total. The kernel is responsible for getting everything else up and running and working correctly. GNU Grub is a very powerful bootloader. It can load a wide variety of free operating systems as well as the proprietary operating systems like Microsoft with chain loading. Grub is designed to address the complexity of booting a personal computer, both the program and this manual are tightly bound to that computer platform, although porting to other platforms may be addressed in the future. One of the important features of Grub is its flexibility. It understands file systems and kernel executable formats, so you can load an arbitrary operating system the way you like without recording the physical location of your kernel on the disk. If you remember that picture of the pt1 that had all those toggle keys on the front of it, the way you booted a pt1 is you told it physically where the first block of the boot kernel, the kernel boot record was, that boot record. So you actually toggled in the address of where the kernel was stored at in order for that machine to come up. With Grub, it knows basically how to go in and find the kernel and execute it. So there you go. So boot block and partition. So this file, and I want to scan up on this a bit. We'll take a look at this in a little bit better detail. Come back here. So sector O contains that boot block. That master boot record is the first sector on the first track in the first cylinder of the disk drive. Makes it easy. The hardware knows where sector 0 is on that hard drive. Sector 0 contains the information needed to get you to the kernel. So that's what's going on there. Okay, let me get back here. We'll go on to the next slide. So in the Unix environment, what exactly is the kernel doing? Well, there are a number of functions. There's system functions, there's networking functions, there's storage functions, memory, processing, and then the human interface. So from a series of layers, from the electronics, the actual physical devices, and then the interfaces, which are the buses, and then the logical piece of this, bridges, virtual subsystems, and user space interfaces. So what you've got is electronics, a bus controller, the PCI USB, the bus drivers, which are the interfaces to make the electronics work together. The logical piece is the system run, the modules, the generic hardware access, processing, file systems, that type of thing, and system calls are the user spaces on the system. Networking, sockets, protocol families, the network file system, the TCP, UDP, IP protocols, network devices, and then cards, Ethernet, Wi-Fi, and the cables, that type of thing. In the electronics environment, for storage, disk controllers, the IDE, SCSI, block devices and drivers, the logical file systems, the extension 3, the extension 2, the NTFS, or even the old familiar FAT. Then there's pages and caches, which get thrown into this virtual file system, that logical volume manager, for instance, and that shows up as files and directories. So you can see how this thing lays out. There is something called dmessage, which examines or controls the kernel ring buffer. The kernel ring buffer is a data structure that records messages related to the operation of the kernel. A ring buffer is a special kind of buffer that is always a constant size, removing the oldest messages when new messages come in. So if I go to, and I'm going to bring up my terminal here, and I'm going to change the look of it just a bit. Okay, there we go. SU dash, I'm going to become root. And now I'm going to type dmessage and pipe that to less. And you can see, here is the last time I booted was Friday, January 22nd. So here's what's going on. There's the Intel, genuine Intel, AMD, authentic AMD. It's actually an AMD device. So I've got a number of things that are going on, but this dmessage contains all of the startup information that you would get from a regular process. So anyhow, that takes us through a little bit of what's going on. Hopefully by the time we come back for part 2, the VirtualBox will have a copy of Solaris loaded. So I will see you in a moment in part 2 of week 8.